Okay, in this little slideshow, I think that you can do this is you put everything into a nice chart. If you recall what what your formula is, right? Y of whatever point you're looking for is equal to y of the PVC plus G1x plus R over 2x squared. All right, so we already determined right before that R is equal to minus 0.9% per station. So we have what R is. All right, X then, in stations, is the distance from your PVC. Right here. So you see that's why it's written that way. So if you start here at the beginning at the PVC, you're at 43 plus 70. To get up to the next full station right here, you've gone 0.3 stations. To get to this next one, as you keep moving up, that's one full station, so that's why you're adding the 1. And adding a whole nother full station, so they're 2.3, 3.3, 4.3, 5.3, and then the remaining 0.7 of a station to get to 49 plus 70 at the very end. Okay, so now you have your stations lined out. Now you can multiply G1 times X. And what did we say G1 was? G1 is equal to plus 3.00%. So all that's doing then is taking, so you look right here, 0 times plus 3 is 0, of course. This one right here, 0.3 times 3 equals 0.9, and so on and so forth as you go throughout your chart. Now when you get right here to R times Rx squared over 2, which is the last part, our correction portion of the equation, okay, you calculate that out. R is minus 0.9% per station. Multiply that by X squared, which is 3%. Excuse me, is X in stations, right? So 6 squared, so if you take that first one right there, 6 squared times R, 0.9, 9 is 0.9 divided by 2, and you end up at negative 16.2. Okay, so all we're doing is trying to make it simpler for you to be able to calculate what that elevation is. So now you have your whole chart as you multiply everything through. The last column right here at the curve elevation, all you're doing then is adding, taking the Y PVC, which we calculated previous, which is what? Which is 844.48. Equals Y PVC. Okay, plus G1X, which is now this column, and then plus R over 2X squared, which now is this column. So you take all that, and that's how you now end up with the elevation at every single one of those. Okay. Now the thing is, what's really awesome here is, like before, we could have calculated what the ending elevation at the PVT is. We could have done that just as we calculate the PVC. Instead of doing minus, L over 2 and going backwards from the PVI, you can actually go forward from the PVI. So if you do that same calculation, which is right here, you get 846.28, which checks exactly what we have right there. So it's a help to you to be able to do that. All right, so now we're doing that. One thing I want to get to is what we can look at on this chart that'll give us some good information, something to know that we're doing something right. We talked before that if you take the derivative of the first equation, then you get the slope at that existing station right there, at that specific point on the parabola, on the curve. And then if you take the second derivative, then you get the rate of change of grade, which was R. Okay, so to be able to get to there, what you can do and find is, and this can only work between full stations now, not part stations, but just full stations. So here's a full station. These are full stations. So what we can do is take the difference of the elevations. So by doing that, I'm taking 847, taking this one, and subtracting. And I get this answer. This elevation subtracted, I get this answer. This is just taking differences. Subtract that, I get here. Subtract this, I get here. And subtract this one, I get there. Okay, so that's the first difference. Now the second thing that we can do is, let's do the same process one more time. I take that, subtract it, I get minus 0.9. Take this, minus 0.9. This, minus 0.9. This. Now this is your check. If you've done everything right inside here, and you end up over here, and this matches what we declared R to be, this is right. This is how you can double check yourself. And again, this only happens between full stations, not any part stations. So again, this is just a check for you to see that as we take the second difference, that's what we're doing. You know, as you took the second derivative, that's what we're able to calculate and do. So by using just the elevation calculations you did, you can do this exact same thing, and that's another check to you. Okay, so now let's have another example. This is a little bit different. Now what we want to do is find out the information you do have and what's known. So if I give you the grade G1 and I give you G2, and I give you a station at the PVI of 52, and then also give you an elevation at the PVI. But what we don't know is L. We don't know the length of this vertical curve. So what I'm trying to tell you is I want you to design an equal tangent parabolic curve to meet a railroad crossing, which exists at 53 plus 50 with an elevation of 1271.2. So this is one of those things where if we're trying to meet certain aspects of it, okay, this is how we're gonna be able to do it. Okay, so what we have to do now is figure out what information we do have, what we're looking for. So when we're doing this design, what we're looking for is trying to find what L is. That's our big thing. So look what as you draw this out, what information you do have. Okay, remember this is right here. This is your PVI. This distance right here, is the distance we're looking for. We're trying to match what this is. Well, we're telling you what this is. We're telling you that there's an elevation there, so we already know what that is. We know then also what the stationing is. Okay, so to be able to figure out the whole distance, what we're doing, because if you remember the equation right here is equal to y of the PVC plus G1x plus R over 2x squared. All right, so what we're looking right here is what x is. We need to know what x is. Well, x is this. Well, if we know right here that if this is your PVI, this right here is the station we're trying to fit. You know the PVI is the middle of the whole curve. So if it's the middle of the whole curve, then you can take the difference between 52 and 53 plus 50, which is 1.5. And then we know that the remaining portion of that distance is L over 2. So that's one thing we just need to make sure we understand what information is really given and what we do have. Okay, right now L is still the unknown, so that's what we're going to try and solve for. All right, so if you take your equation, again, the y of PVC plus G1x plus R over 2x squared. All right, now let's figure out, all right, what can we figure out? What information do we have? What we knew is we're trying to, by using L, we knew an elevation here. We knew that distance, right? Okay, so at that point right there, we're going to say 1271.2. Y of PVC. So how are we going to calculate Y of PVC? Okay, well, we don't, to be able to do that, right, we need to know what the elevation at the PVI is. Then you're going to come back to, we need to then, right, if you look back what the look of the curve was, right, here's what your curve looked like. All right, so if we're at the PVI, we can calculate back up to this point right here to get what it is. We knew our grade then, right, this is minus 4%. Right, to get back to the front right here, what are we doing? We're multiplying L over 2 by the percent grade plus the elevation at the PVI, which then gives us the elevation of our PVC. So we're just plugging this information in, and that's what you get right here. Okay, G1 times X. G1 we know. And what did we say X was? X was L over 2 plus 1.5, what I showed you on the previous slide. Then we need what R is. That's the one last little thing. So to be able to figure out then what R over 2 times X squared, well, what was R? R is equal to G2 minus G1 divided by 2. Okay, so now if we know what G2 is, we know what G1 is, we can plug in then what 2 is. And then we multiply that then by, excuse me, it's not making question. I need to make a correction right here. I've been telling you guys wrong. I really apologize about that. Anyway, it says G2 minus G1 all over L. I really apologize about telling you the wrong thing. So as you get this, then it comes over to there. Okay, then multiply that by what x is, L over 2 plus 1.5 squared. So I apologize about that. We'll make a correction on that. Make sure that there's a correction in the notes on that. All right, so as you do that, what you're going to want to do is you need to simplify the whole equation. You're going to simplify it, and it's going to come down to a quadratic form. You're going to take that, solve the quadratic, and then you end up in figuring out what L is at 9.1152 stations. And once you get to there, now we have our complete design. Now we know what L is. We know G1, G2, we know R. We can figure everything else out to be able to figure out every elevation along there.